Hey folks, welcome back for another episode of Code Club. In the last episode, we made this figure, which is actually 4 figures, compiled together into one using a package called Patchwork. In today's episode, I'm going to show you how we can make basically the same figure, hopefully a bit better, without having to use Patchwork, using a single ggplot2 function using something called facets. This figure comes to us from a paper published in the ASM journal AmBio, titled A Molecular Comparison of Iron-Sulfur Cluster-Based Homeostasis in Escherichia coli and Pseudomonas aeruginosa. What all that means, really don't worry about, right? And so what we're trying to replicate is figure 2D, I believe, or C, figure 2C, shown here. And in this study, what they did is they took Pseudomonas aeruginosa, that's PA01, and they knocked out the ISCU gene, which is a gene involved in making iron-sulfur clusters in proteins. Again, don't worry too much about it. And so what they found was that when you take the wild type, the PA01, the Pseudomonas aeruginosa, and you treat it with 4 different antibiotics, that PA01 over time loses its viability, right? It dies when being exposed to any of these 4 different antibiotics. But when they knock out the ISCU gene, that at least for gentamicin, afloxacin, and meropenem, it then gets resistance to these different drugs. It's still sensitive to clistin. When they then bring back in the ISCU gene using an arabinose-inducible promoter, again, don't worry about what that means, that basically recovers the wild-type-like activity so that you see this dark red line overlapping with the dark black line for the 4 different drugs. And so again, in this original figure, they effectively generated 4 different plots. My sense is that they made this original plot probably using Prism. And so I then tried in the last episode to recreate that plot using ggplot2, and as I mentioned, Patchwork. I think we did a pretty nice job, but if you recall the code from that episode, we did a number of things that aren't really the R way of doing it, right? It made things, I think, a bit more complicated than what it needed to be. And that's what I want to do in today's episode, to show you the easier, I don't want to say it's easy, but easier way of making this 4-panel plot. So I also printed out the figure and marked it up. Yes, I still like to work in physical reality. As much as I like programming, I still like to have kind of the tangible figure and text at my hand so I can mark it up with Sharpies and pens and whatnot. And so there's a variety of things in this figure that I didn't quite like. So the first thing that I want to highlight are these blue circles, and they're highlighting the axis titles, right? So first of all, the CFU per mil is a unit. It's not descriptive of what it's actually measuring, right? So the CFU per mil is a measurement, but what is it measuring? I prefer to have both on my axis titles, right? So we have like time, that's what we're measuring, and we're measuring it in hours. Well, what are we measuring in CFU per mil? So I would like to remedy that. The other thing then is that we have all these axis titles replicated for each of the 4 figures, as well as the values on the Y and X axes. It's a bit redundant. And so using facets in R with ggplot2, we should be able to have a common Y-axis and a common X-axis. I envision the same figure where we have 4 panels, we have 2 rows and 2 columns, but where the Y-axis title and labels would be over on this left side, and the X-axis title and labels would be on this side, on the very bottom. What this then would do would declutter the figure. It would also give us more space to kind of stretch out the data a bit. The second thing I want to call your attention to is in the red, my arrows to the limit of detection. That basically, I think we had about 500, or actually we had controversy over that, right? Was it 500 or 100? See that last episode if you want to know what I'm talking about. Basically, this axis line on the x-axis where it crosses the y-axis, they're effectively using as their limit of detection. And so what I'd like to do is go ahead and draw a line and indicate that that is the limit of detection, okay? The third thing that I want to think about in terms of this plot is that these staples, which is the horizontal part of an error bar, are kind of big and overlap, right? So up at like 0 hours, we have 3 lines here, and they overlap each other, and you can't really see anything. Now, of course, there's really nothing to see here. I think that's kind of the point. But it might be nice to think about ways that would allow our audience to see those error bars a bit more cleanly if we did want to be able to kind of highlight the difference there. Over here in RStudio, I have the code from the last episode, which again, you can get from that previous video, which I'll link to up above here. And what I did in that episode was made a function that generated one panel of the plot. And I took my data, which was fig2c data. With that data, I then filtered it by the drug, each of the 4 different drugs, and I then summarized to get the mean and the standard deviation by the strain and time. And so this works, but in recent episodes, I've been showing you a little bit more of a sophisticated way to do it using stat summary. And so I want to incorporate stat summary to make this simpler, as well as removing the whole function aspect, which I then called 4 times, to use facets. And I think what we'll end up doing is use facet wrap. And effectively what that will allow us to do is have the same amount of code that's in the function, although with 1 extra line for the facet wrap, which is no big deal. And we can then get rid of all this extra code that we had to write to style things properly using patchwork, okay? So I'm going to go ahead and take the top part of this, and I will create a new R script. And let's go ahead and remove some of these extra packages that I don't know that we need. And I will go ahead and run this code here in my RStudio session. As always, if you want to get this code, down below in the description for this episode, there's a link to a blog post that you can go to get all of the code that I will be generating today. Also down below in the description is a link to the original paper, as well as a link to a newsletter that I write that this particular one that I'm linking is describing this set of figures and kind of how I would go about tackling regenerating that figure from kind of a very high level view. So again, we have fig2c data, and that gives us a tibble, a data frame with the drug, the strain. Again, there's 3 strains, 4 drugs. The replication, there were 3 replicates, 4 time points, and then the density of the cells in the assay, right? And so let's go ahead then, and I'll take fig2c data, and again, if we do ggplot AES on the x-axis across, we're going to do time. On the y, we're going to put density, and then we're going to color by the strain. Let's go ahead and do geom line. And so this makes a hideous mess, but we can see the starting of a figure. So across the X, we have time, Y is the density. We have our 3 different strains. We get this sawtooth shaped look to the figure because we have 3 replicates for each time point and each drug, right? And so basically the line, this pink line here, red line, is connecting 12 points, right, at 1 hour because there's 4 drugs and 3 time points, so there's 12, right? And so what we need to add to this is an ability to do the summary. So again, in the last episode, before feeding it into ggplot2, we used summarize where we grouped the data by the time and the drug. And so now what we can do is before we summarize it, let's go ahead and facet it. So we'll go ahead and do facet underscore wrap, and then we'll do tilde, and I will do drug, and I'll do nrow equals 2 and col equals 2. So now we get our 4 panels. You'll notice they're in a different order than what I made them in. They're actually in alphabetical order, so we'll need to be sure to come back to that in a bit. We've got our legend off to the right. We have a common legend, and then we have a common x-axis and a common y-axis, right? At least we have the common title for each, and we don't need to put these densities to the left of, say, this gentamicin or the left of this afloxacin, right? And so our data is going to be much more compact, which when we get rid of that legend, if we use the same dimensions for our figure, will give us a lot more space to visualize the data, and will, again, obviously make it a lot less cluttered. All right, so now we need to deal with this replication. So to do that, I'll do stat underscore summary, and we'll do a geom equals line. And let's go ahead and so we'll do fun.data. I'm going to use mean underscore SDL. SDL is the standard deviation. I think it actually has a multiplier. So let's look at that documentation, mean SDL. And yeah, if we look at mean SDL, does it tell us anything here? No. So let's look at HMISC S mean SDL. And so we have mean SDL, and the multiplier is 2. So in the original paper, they used mean plus or minus the standard deviation. So to get the mean SDL with one standard deviation, we can do fun.args. And I think this takes a list. And so we'll say molt equals 1. And then we'll go ahead and add a plus to that. So the output here looks a bit odd. I have a line going through the data I can see here, but I still have, it seems like lines connecting the other replicates, right? And so if I kind of toggle back and forth here, you can see that. And sure enough, line 55, I still had geom line there. So let's go ahead and rerun this. And so now the lines connecting all the replicates are gone, and we can now see our lines, right? The summary going through the mean. So let's go ahead and add our error bars. So stat summary, we'll do geom error bar, and then the same arguments for everything else. For this line, we didn't actually need mean SDL. We could have used plain old mean without these extra arguments. But let's go ahead and roll with this for now. Now we see that our error bars have been added to the plot, and we have all of our geoms added to the figure at this point. And so now all we have to do, is to make it look halfway attractive. So let's start on that by going ahead and let's move our legend to the bottom. And so to do that, we'll go ahead and do theme classic to clean it up a bit. That's not going to do anything for the legend per se, but let's go ahead then and use theme, and we'll do legend.position equals bottom. And so now we've got our legend across the bottom, and we have more space on the side. And before I get going too much further, I would like to go ahead and save this out to file so that I can kind of see the final dimensions that I'm going to be working with. So I'll do ggsave, I'll do iron sulfur resistance .png, and then the width and height that I used from before, width 9.87, height equals 8. So again, this is a start, and we have a bit of work to do to clean things up. One of the first things that I would like to do is deal with that last issue that I commented on my marked up version of the figure, which is this overlap in our error bars. And instead of error bar, I think what I'd rather use is perhaps the line range. So let's try line range. So that cleans things up considerably to not have these wide staples on our error bars. But at least at like the 0 hour for sure, there's a lot of overlap. And also at 1 hour here, I can see there's overlap as well for the meropenem. So I'd like to try position equals position dodge, and then width. Let's do 0.2 and see what that looks like. And I'll add the same thing down here to my line range. We've seen this in previous episodes that we need to dodge both statistics if we're using stat summary twice, so that our line goes through those dodged points. And so now we can see that these are dodged, although there's, I don't know, a fair amount of separation between those. And so maybe I'd like to have less dodging. So let's come back and do 0.1 on both of those. So I think that level of dodging looks pretty nice, and I'm happy to roll with that. Let's go ahead and turn our attention then to the y-axis, because setting that y-axis on a log scale will really give us better perspective for what the overall figure looks like. And so let's, down here after the facet wrap, we can go ahead and do scale y log 10. So yeah, that y-axis gives us a better perspective of the size of the variation and kind of the difference between the different strains. And I'm pretty happy with the way that looks. Again, I think if we put those caps back on the error lines, the point ranges, to get true error bars, then they're just going to run into each other, and it's just going to kind of make the plot a bit messy. All right, let's continue to play with that y-axis. Let's start with our breaks. So our range goes from basically 10 to the 3 up to 10 to the 7. I think it's really more like 500. So let's start by putting in limits. And we'll do C 1e to the 2 to 1e to the 7. And then we'll do 1e to the 2 up to 1e to the 7. So we'll do 1e to 3, E4, 1e6, 1e7. Great, and that gives us those y-axis labels. Let's give it a more attractive y-axis label. And so we can do labels. So we saw this in the last episode where we can use glue. So let's go ahead then and add library glue. And actually I put C glue, so I want glue because glue will make the vector for us. And so in quotes, we can then do 10, and then we'll do superscript, and then we'll close the superscript. And inside of this superscript, we want to put the range of values. And so we're going to go from 10 to the 2 to 10 to the 7. But to inject our code into that glue statement, we need to wrap it in curly braces, right? And so if we run this glue statement, we now see we've got basically this HTML, right? And so then to get that HTML to render, within theme, we're going to do axis.text. And I'll make both X and Y element markdown. If I only wanted Y to be element markdown, then here I could put .y. But I want to treat both of my axes the same at this point. And I was so excited to use element markdown that I forgot to load the package. So we'll do library ggtext, and let's retry this. And so now you can see on the y-axis, we have our superscripted 10 powers. Of course, those are gray and they're not black. We can do color equals black. And so now we have our black y-axis with the superscript as well as the x-axis being the time. Great. One other thing we learned in the last episode was how to put the minor ticks showing the log scale graduation between, say, 10 to the 6 and 10 to the 7. And we can do that by coming up here to scale y log 10 again. And we can do guide. And guide is basically the legend, right? And so we've seen this in other places where perhaps we had a plotting symbol that was small in the legend and we wanted it to be bigger, right? And so we could use the guide where we would then override the size of that plotting symbol. And so we'll do that also here. And we'll do guide axis log ticks. We now see on our y-axis that we have those ticks. It gives us a tick for 5. That's a different size as the tick for 1 or the other ticks within there, right? And so I think I want to keep all the ticks the same size. The 3 tick sizes are long, mid, and short. And if we want to know the actual tick size, we can look at the help for log axis guide ticks. And we see that long is 2.25, mid is 1.5, and short is 0.75. So I'm going to go ahead and make long equals 2.25, mid I'll make 1, and short I'll make 1. And even though I'm not changing long, I'm going to write it out here like I have, because if I want to change things later, then this will help me to kind of think about the relative sizes of those different tick marks. So I like this proportion of the shorter ticks to the longer ticks. While we're thinking about legends on our axes, I'm going to think also about my legend for my color. And I see that I've got the point range legend, which is the vertical line, as well as the line legend, which is the horizontal line. I think I only want the horizontal line. So I'm going to turn off the guide or the legend for the line range. And so to stat summary, I can go ahead and do show.legend equals false. All right, so that got rid of the vertical line, right? And so now I want to play with the legend that we have to change the color of the lines and to change the text that is associated with each line. And of course, I'll also want to get rid of strain as the title of the legend. And so all that we can do up here. I'm going to put that right below my scale y log 10. I like to keep my scales all together. We'll do scale color manual. And we'll do name equals null. And I need a plus sign down here. And that name equals null. I was going to show you that it removes the title, but it wants the other information as well. So I'll show you that in a minute. In here, we'll go ahead and put the breaks. And then we'll also put in the values. So I'm going to put the breaks in, the values for those breaks, in the order that I want them. So I'll start with PA01, and then mutant arabinos. Arabinos. All right. And then our values are going to be the colors. And so I'll do black, and then pink, and dark red, which is close to the color scheme that they used in the original figure. And so now we see across our legend that they're in the order that they were in the original figure, and that our lines have those colors, right? So the mutants tended to be resistant, whereas PA01 was sensitive, as was the mutant plus arabinose. So that all checks out and looks good. So now I want to go ahead and put in the more attractive text for the labels in my legend. And so I'll do PA01. And looking back at this, it's delta ISCU. So I will shorthand that with D ISCU, P era ISCU. And then I'm going to copy this for the time being. And this I need to mark up with HTML or Markdown. And so that capital D should be a delta. I can do ampersand delta semicolon to get a capital delta, and then a star around the ISCU. That is Markdown for italics. And then I'm going to put a space between that U and the P. And then the era is going to be a subscript. So we'll do the sub tag, and then back out of that with the sub tag. And then again, the ISCU will also be italicized. And so then what we need to add for this is legend.text equals element markdown. And I'm going to move this up in my theme function so that I keep my legend stuff together. So now I see that the label for the mutant looks good. And now I need to adjust the label for the mutant that gets the arabinose. And so I'll go ahead and copy this over, replacing this dummy text I inserted. And let's go ahead and put all these on separate lines so they're easier to see. And so then over here at the end, we'll do plus 0.5% era. Oh, and it's upset that I forgot a comma here. Very good. And now we have our labeling. So when I mentioned that we're going to go to using facets, I thought it would give us a lot of space, and it seems to give us a ton of space, right? So I think I'm going to try to go ahead and shrink down the size of the plot. And so like a typical width on a figure, like a 8.5 by 11 sheet of paper is 8.5 wide. You figure 1-inch margins. So that gives you like 6.5 inches wide. Let's go ahead and make it say 5 wide and 4 high. Basically, cut both dimensions in half. And so then what that does effectively is make our font bigger relative to the rest of the data. And I think that actually is going to be a bit more of an attractive figure. So I'd like to get rid of the space down here below my legend. And let's see if we can do that with legend.margin. And we'll do margin. And let's do zeros all the way around and see what that looks like. And so I think that did get rid of the margin at the bottom. I think there is a plot margin at the bottom. And so just to test that out, let's go ahead and do plot.margin, and we'll do equals margin, and then b equals 0. So that did remove a bit of margin on the bottom. It also removed the margin all the way around the rest of the plot. There's another legend margin that I think is legend.box.margin right here. And let's do margin on zeros all the way around on that. All right. So there's still a bit of a space at the bottom here. And sometimes it's hard to know where the margin is coming from. And so one solution that I have found to be helpful would be to do like legend.background, and then to basically draw the background, draw the border around that element. And so let's do legend background, and we'll do element rect, and we'll do color equals black to make a black border. So what I'm seeing then is that there appears to be a margin between the top and bottom of the text and the top and the bottom of the legend background. And why is that? Well, I think that's because the key is actually taller than the text. And so the legend box is going to the height of the key. So let's come in here then, and we'll do legend.key.height, and let's shrink that down. And so we'll do unit, and I'll say 10 pt. And sure enough, that collapses things down considerably to basically the height of the text. And so I'm happy with the way that looks. I'm going to now get rid of that background border. And so now we have our legend right at the bottom of the figure, and that looks good. Now we have this issue where the space between the key, the text, and the next key is the same. So to resolve that, I'm going to go ahead and add some space to the right margin of my legend text. So I already have legend text up here where we used element markdown. I'll do margin equals margin, and then R I'll make, let's try 20. Good. And so that gives us a lot of space. Maybe we could take that down to say 10. And then I noticed it removed the space from the left. So let's do L equals 5. And so then I think that gives really nice spacing between our three different elements in our legend, right? Cool. So now let's go ahead and fix our X and Y axis titles. And to do that, we can come back up and perhaps between my scale and my theme classic, I'll do labs. On the X, I'll do time in hours. And then the Y, I'll say cell density, and we'll do CFU per ml, and then get that plus sign. That's good. I'm noticing as I put in that y-axis that I removed the margin around the whole plot. And so I think that was here with plot margin where I put b equals 0. So let's turn that off for now. And that gives us a bit more spacing around the entire figure. So actually, let's go ahead and put that back on, and let's make it, let's do 3 all the way around to keep it pretty tight. And I think that will look pretty good now. Good. Now we've got our X and Y axis titles, right? We only need one title per each. And as I'm thinking about this Y axis, that we only have the Y axis on the left side, we don't have our grid lines, which we had previously. So let's go ahead and add that. And so we'll do panel.grid.major.y equals element line. And we'll do color equals gray. And so that gives us our grid lines, but those are pretty thick grid lines. So let's go ahead and reduce that with like line width equals 0.25. And I still feel like that is still too thick. So let's go down to maybe 0.15. And I think that's a pretty nice thickness on our lines, and I'm happy with that. The next thing that I want to turn our attention to is that limit of detection. And so in the last episode, I had this kind of angst about what is the limit of detection and how they were drawing their lines. So in theirs, the line went down below the x-axis, indicating it went below the limit of detection. And so I think what they did was they used 490. And so when I simulated the code for those values, I put in 490, okay? And so I think what I'll do instead of 490 is I'm gonna put in 100, and so we'll place all those 490s with 100, and I think that's all of them. And so then what we'll do is we'll go ahead and I will then draw in the line at 500 as being the limit of detection. So let's come to our code, and I want this line to be behind the data. And so we'll do geom_hline, and we'll do y-intercept equals 500. And let's see what this looks like before we do anything. So this gives us a solid black line all the way across. Maybe I would like a thin dashed black line. So let's come back up to our geom hline, and let's do line width equals 0.5, and then line type, let's do dashed, and that's still too thick. I think that was actually the same thickness we had before. So let's go ahead and reduce that further. Let's do 0.2. So this gives us that dashed line that looks pretty nice. I'm going back and forth on whether I like that dashed line. It adds one more horizontal line to the plot, which makes things kind of cluttered. It also then includes these values as going below the limit of detection. And I don't know that I really like this look. So I think maybe what I'll do is I'll combine both approaches, okay? So I'm going to bring up the Y limit to be, let's say, like 101, so that I'm not showing 100, okay? So let's try that. And that way then we'll still have this dashed line at 500. I think I like that. Let's try that. Okay, so we'll come back up here to scale Y log 10. And here I'll do 101. And so it's complaining because scale Y whatever will remove values that are below the limits. So I'm going to remove this limits from here, and we'll then do chord Cartesian, and we'll do ylim equals whatever I had here, right? And so we'll plop that there, and maybe I'll move my chord Cartesian up before my scale y log 10. Make sure I get a plus sign on that. Oh, and I'm forgetting a parenthesis here. That's why it's indenting things weird. And so we're still seeing the 10 to the 2 here because we have the expand on the y-axis. I like the expand being on the x-axis in this case. So to scale y log 10, I'll do expand equals c 0, 0. So I like this look, but I'm noticing that I have a top of the line for the gentamicin. And I think my limit probably needs to go up a bit. And I'm kind of look back here and see what I did. For gentamicin, it was 100, and for afloxacin, it was 100. And so I think we're just not seeing the top of the afloxacin because we've got the axis there, right? So let's go ahead and bring up the limit of our y-axis. So let's make that 110. And so then that did get rid of the top line. So the next thing I want to turn my attention to are the facets. So there's 3 things I need to do. First, I need to change the order of the facets to match what they had in the figure. I need to remove the box around the facet labels. And then I would like to right justify the text of the facet label, right? And we'll try both left and right. Currently it's centered, but I would like to kind of have this be off to one side or the other. And now that I think about it, I think I'd probably rather have it be left justified because we tend to read things starting in the upper left corner, right? And so I don't want to have to look over to the right to see that it's gentamicin or colistin. I'd rather it just be right there at the top of the data, you know, right around here where I have my crosshairs, right? So let's try that. Okay, so to reorder those panels, we need to make drug a factor. And so I'll plug that in my pipeline where I'm making the plot. I really have, so here I have 2 pipelines. I really only need 1 pipeline, but hopefully you get the idea. We'll do a mutate on drug. So we're going to take the column and we're going to change it to something else, which is a factor on drug. And then we'll have levels. And then we're going to define the order of the level. And I know the top left is gentamicin. And I think the last one is colistin, but I forget what's in the middle. So again, it's afloxacin and meropenem. So we'll do afloxacin and then meropenem. And I'm remembering that the drugs are capitalized in their first letter. Okay, so this then should reorder drug to be a factor that is in the order of gentamicin, afloxacin, meropenem, and colistin. Previously, what it was doing was alphabetical. It would go colistin, gentamicin, meropenem, and afloxacin. And so we'll add this into our pipeline. Very good. We now have our 4 panels ordered the same way that they were in the original figure, and that's great. Now let's go ahead and remove the border on each of the panel titles. And so we can do that down in here. So that is set by the strip argument. So we'll do strip.background and we'll do element blank, and that removes the background to the strip. And now what I want to do is left justify my titles. So we'll then do strip.text, and we'll do, that's going to be element text, and we'll do hjust equals 0 to make it left justified. And so now our titles are left justified. And I think that looks pretty good. Let's try the right justified. That would be hjust equals 1. And so that's right justified. And so again, I don't want my audience to have to look over to see, oh, that's gentamicin, and then come back to the left and then interpret back to the right. I think if we leave the title on the left, then they can look at this upper panel, see it's gentamicin, and then interpret the figure from there. So let's go ahead and put this back to 0. So I'm pretty happy with the way mine turned out. Again, the data on the left is the same as the data on the right. Well, it's my simulation of their data, but you get the same kind of trends here. So what I like about mine, of course, is that it's cleaner. I don't have so much redundant text in for the y-axis or for the x-axis. I guess the downside would be that, you know, if you want to know what this line is, what this grid line is, you have to look all the way back to the left to see that it's 10 to the 6. I don't think that's that big of a deal. I really think that this figure is giving more of a qualitative interpretation of the data than a precisely quantitative, right? So with the afloxacin, I can see that the mutant stayed resistant, whereas the wild type and the complement really just were not resistant. They're pretty sensitive, right? And we're not concerned about, you know, specific values or numbers at these different time points. We're interested in more of the overall trend. One thing I noticed with theirs is that their lines are a little bit thicker than mine. I don't know, maybe mine are a little bit too thin. Why don't we maybe play with that just real quick here before we say goodbye? And so in here with the stat summary for the geom line, do line width equals 1. And so that gives me a thicker line. I do feel like that's kind of too thick. So let's try 0.75. I believe the default is 0.5. So let's try 0.75. And I think that's a nice bold thickness that's not overwhelming. And then having the line ranges be thinner, I think is good. Let me know what you think of my facet approach versus the composition approach. One of the things that I really encourage people to do is to learn these tools. Learn facet wrap, learn facet grid, learn to use patchwork. I think the absolute worst thing that you could do is to generate 4 plots and then take them over to PowerPoint and then assemble them together. That just, part of me dies whenever people do that, right? And why does part of me die? Well, because I've done that before, and it's painful when you have to go back and change all 4 of your figures because someone doesn't like that you used pink for the mutant. They'd rather that you used, I don't know, gray, who knows? Because then you have to reassemble all those panels together, and that's just painful. The way I've shown you to do it, whether it's with patchwork and writing a function or using facet, like we did today, is reproducible, right? If I wanted to change that pink to green or to gray, I would change one line of code, not even one line of code. I would change pink to gray, rerun it, and get the figure to pop out, and I wouldn't have to take things to PowerPoint or Illustrator or whatever crazy things people do. I would really encourage you to learn these tools. Learn facet wrap, facet grid, as we've done today, or patchwork like we did in the last episode. Patchwork will allow you to combine all sorts of different types of panels, right? You could even put in images, right? So like if you think about this plot on the right made with patchwork, well, the upper left quarter could perhaps be a gel image, and the lower right could be more of a dot plot, and the lower left, I don't know, could be a pie chart, right? And so you can have 4 very different types of plots coming together with patchwork. I like using facets when I've got, say, 4 or 2 or more plots that are of the same type with the same data. And I think it does a really nice job of simply presenting the data without having all kind of the extra baggage that we see in the plot on the right. Let me know what you think. These are strong opinions, but they're opinions. And I'm very happy to be swayed to have another opinion. But let me know what you think, and let me know why you think that. All right, well, please share this episode with your friends and tell them about all the cool stuff we're doing here on Code Club. And I'll see you next time for another episode.